Hi guys, in this video we are going to review Green's theorem. Green's theorem is used to evaluate line integrals, but they're not just random line integrals. These are line integrals over a circular path, which means that the start and the end of the path has to be the same exact point. Also, what's important, and I have this arrow here to indicate that, is that the orientation whenever you are walking over this path has to be counterclockwise. So if it is clockwise, all you got to do is just switch sign. Okay, so just put a negative sign in front of the whole thing. Let's see what kind of orientation we have here. So we're starting at 0, 0. Then we're going to 0, 3. So we're going this way. Then we go to 2, 3. So 2, 3 would be over here. Then we go to 2, 0. And then back again to 0, 0. Now, does this look like counterclockwise or clockwise orientation? I think this looks like clockwise orientation, which means that we will have to insert a negative. Okay, so what does this Green's theorem say? Green's theorem says that we can just find a double integral instead of the line integral that you see there, which, by the way, this would be p and this would be q. Also remember that if this was a minus, that minus would be actually part of q. But in this case, it's a plus. So I don't have that problem, but just remember that. Okay, so p equals 5xy, and then q equals 8xy squared. P being what we're integrating with respect to x, and q with respect to y. All right, now, so what is the point of switching from a line integral to a double integral? Why would we even ever have to do that? Wouldn't double integral be harder? The question is very important, right? But the answer is this. If you actually had to compute a line integral here, you would have to compute 4 line integrals, because this curve, in order to make a parameterization, you'll have to parameterize this first line segment from here to here, then C2, then C3, then C4, and then compute each of the line integrals separately and then add them up. I don't know if that sounds like fun to you, but it doesn't sound like fun to me. So I am not going to do that. Instead, I'm going to use Green's theorem. So Green's theorem says this. Why don't we double integrate over the region enclosed by this curve? And remember, this is closed curve, which means that there's going to be some region inside. And this region is a rectangle, so it's pretty easy to integrate over the rectangle for. And let's set it up. So we're going to have dy dx. So the x limits will be the outside limits, and so those will be 0 to 2. And then the y limits will be the inside, right? This would be the inside. This is the outside. The y limits go from 0 to 3. Okay, easy enough. Now let's see what are we actually integrating. So what are we actually integrating is q with respect to x minus p with respect to y. What is q with respect to x? That's the partial derivative of q with respect to x. That will become 8y squared. Minus, now let's integrate p with respect to y. That'll become 5x. Okay, now the only thing that I still have not done, and I'm supposed to do, and that is switch the signs, because the orientation was, remember, clockwise. If it was counterclockwise, this would be the answer, but because it's clockwise, I just will switch the sign. So I'll make this negative, I'll make that positive, and that'll be it. Okay, now let's evaluate this integral. It's not hard. Very easy. This integral is not splittable because I got a sum of two things here, that one has y, one has x. So unfortunately, I can't do a shortcut here. I do have to integrate each part. So the first part is negative 8y squared with respect to y will become negative 8 thirds y cubed. Plus, now integral of 5x with respect to y. Think of number, right? Integrating number is number y. And then I'm substituting y equals 0, y equals 3. It's important to write down what variable you are substituting for, or because now you have two different ones. The first term becomes negative 8 thirds, 3 cubed, plus 5x multiplied by 3. 0, easy. When I substitute 0 for y, I'll just get 0. There is nothing else there. Let's see if we can simplify this further. 3 cubed divided by 3, that's just 3 squared, so that's 9. 9 times 8 is 72. I got negative 72, and then I got plus 15x. Okay, integrating that, negative 72 with respect to x just becomes negative 72x, and then plus 15 over 2x squared. I am substituting 0, 2. All right, when I substitute 2, the first term becomes negative 144 plus 15 over 2 times 2 squared. When I substitute 0, that just becomes 0. So this is negative 144 plus 30. And I think that would be negative 114, and we are done.